Route 53 configuration. I'm going to assume at this point that you have the concepts of Route 53 down, meaning you know what DNS is, you know what Route 53 is, you know what the benefits are to run Route 53 on AWS. So take all those, put them to the side and park them, and let's drive right into the AWS Route 53 configuration, starting with the brand new domain registration, at least as it stands today. We'll then get into taking our hosted zone, configuring the base resource records, and then spend a special amount of time, because it will be a special time. I meant a significant amount of time on the redundant records and the health checks, kind of the things that make AWS unique. And I will say the redundancy, the weighted and the GeoDNS, all those kind of things can be confusing if you haven't seen them before. Well, before we jump in, I want to hit you with the do I know this already question. So pause the video, read through these questions. If you know the answers to them, you probably don't need the information that's in the nugget. Otherwise, let's get started. I'm going to start off from the AWS Management Console. Route 53 over here on the left-hand side with all the other core services of AWS. Click on that and I'll have 4 options: the dashboard, hosted zones, health checks, and domains. So if I wanted to start by registering a domain, that's what the domains tab is for. Now this is currently a brand new feature to AWS and actually amazed me when I registered this domain about, 16 days ago now, that it was active in about 15 minutes, which usually that takes about 24 hours to spread around the world. Nonetheless, AWS and some wizardry that they do had it active. Now, if you've ever registered a domain before, AWS is pretty much the same thing. They don't provide all of the extensions that are available, but they do provide the most common. So I will say fluffybunny.com. And I'll hit check. When I was a kid, my cousin would always squeeze my cheeks to where my lips would puff out, and she'd say fluffy bunny. And now I do that to my children. I'm like, say fluffy bunny, fluffy bunny. But obviously I cannot register that domain name because it is a unavailable domain. But you can see right down the list, these are the ones that are available, and you can register them. Different prices for different domains based on the extensions. Now again, there are literally hundreds of these extensions nowadays, so you can see that at least right now, with Amazon starting off in the domain registration world, there's just a few, but the most common ones that you are able to use. So if you wanted to continue, I would say, okay, well, I'm going to add, fluffybunny.ca, wherever that is in the world, to my cart. Continue, and it just walks you through the typical registration stuff where you can go through and register the domain. But we're not going to go through that because I had already registered that cbtnuggets.aws.com. Now, the beauty is you can transfer a domain into AWS or you can register it here. As soon as you register it here, it automatically adds it all to Route 53. When I registered it, I actually got excited and created the zone manually, and then it did it all for me, and I was like, I should have just waited. Anyway, hosted zones is where you can go to manage the zone itself, and you would see all of the different zones that you have created right here. Now, you can even create a hosted zone for something that you don't have. For instance, I could come in and say, you know what, I want to create the domain name Microsoft.com and create. Right? Essentially, your DNS servers, or the ones assigned to your account, are now going to say, okay, well, we will say that we have the domain name for Microsoft.com, and you've essentially hosed your internal registration. Like when your servers try to do updates from update.microsoft.com or whatever it is, they won't be able to find it because the DNS servers assigned to your account have this bogus domain. So you don't want to do that, but that does give you the ability to set up lab testing, all those kinds of different domains, right? So I'm going to go to cbtnuggets.aws.com, which is a real zone now. And you can see right from the beginning, not something I created, something that Amazon created. I've got cbtnuggets.aws.com, start of authority. Oh, actually, I forgot to delete this. I created that when I was playing around. Pretend it wasn't there. Start of authority, saying here's all of the base settings for this. You can see the default time to live, all of those options filled into the value there. Right above it is the name servers, the NS record, saying to the world, if anybody wants to resolve cbtnuggets.aws.com, we are the authoritative name servers that you can come to get all the subdomain names. So let's create some records. The first one that we'll create will be the most common record in existence, and that will be the A record, the address record. So I can type in whatever name I wanted to type in. Let's just say Amazon.cbtnuggets.aws.com. I honestly don't even know if this will work, but we'll give it a try. I'm going to go to command prompt and just ping Amazon.com. And it looks like Amazon is reporting back that that is their IP address. So what I'm doing is I'm creating a little address record called Amazon.cbtnuggets.aws.com and pointing it to whatever IP address Amazon is reporting as theirs. Now you can see right below, this is where if you wanted to, you could set up all of the different, we'll call it advanced routing or advanced pointing mechanisms of Route 53, which we'll cover in a little bit. For now, I'm just going to leave it as simple and hit create. Now, I can, if I wanted to, for instance, come to this A record and add multiple addresses to this list. So I could come in here and do a command, and for instance, I looked up Amazon.com. I'll do a ping to www.amazon.com, which probably, I thought so, will give a different IP address. You can also find these out using NS lookup or a tool like that. And now you can see I have multiple A records, address records assigned to a single record. Now the default behavior, even on a simple routing policy, is to do round robin, meaning the first person that asks for the IP address to Amazon CBT Nuggets AWS will get the first IP, second will get the second, and then bump, 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 back and forth it goes, right? So let's check it out. Again, I think in the previous nugget I said, how long does it take for that to take effect? 60 seconds for all the AWS servers worldwide on average to get that record. So let's just do an NS lookup. And you can see the server, the DNS server I'm using right now is 4.2.2.2, just a public DNS server. I can do Amazon.cbtnuggets.aws.com. Bam! Just like that, it's showing the results. Now, check it out. Oh, this is so good. Check it out. What's it listing first? 172.32, blah, 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 right? Because 176.32, because it's using that little round robin. It's saying, okay, this will be the first one. Now, the next time I look it up, now that's going to be cached, so it's just going to give me the same one from this server. But let's just try it. I'm doing this unscripted, so let's go to another DNS server, 4.2.2.3, and look it up again. Oh, I was hoping something different would happen. Let's do server 8.8.8.8. Yay, there we go. So I'm just bouncing around to different DNS servers on the internet, and you can see this one, it just happened to be, 172. Here's my guess. 4.2.2.2 and 4.2.2.3 is managed by the same entity, so I'm guessing they share a cache, right? So when they get one lookup, they kind of replicate that to all of them, so that's why we got the same thing. The second lookup, or quote-unquote second real lookup, which was from a completely different DNS server, which is Google, came back with a different result. So we can verify. I don't know why. I'm like, see, I was right. Do you ever feel that? Like you have to prove yourself? Anyway, so let's see if it actually works. Amazon, oh, hang on. Shrink it down there. Amazon.cbtnuggets.aws.com. Bam, look at that. We've got Amazon showing up with our own little custom domain name. Now, that's not always going to work. Here's why. I'm going to make a shortcut for my blog. Let's come back here, and I'm actually going to do a different kind of record. Let's create, anyone remember which one kind of acts as a pointer to another DNS name? Show of hands. Yeah, you, sir. CNAME. CNAME is exactly right. CNAME, conical name, allows me to create a DNS record and point it to another name. So I could do my blog, blog with another guy named Adam, is TechCert.com. I could tell you such a long, sad story. I used to own the blog name CiscoBlog.com, and I had that for 5 years, and it was awesome, and it was glorious, and then Cisco came and took it from me. But it's a long, sad tale, and I'll save you all the details, but it was very sad. So now I have www.techcert.com. Now, what's the problem with this? Will this work? Honestly, I don't know. I haven't tried it yet, but I'm guessing it won't. Why not? Because when you set up a website from TechCert, I'm not even, Adam kind of takes care of all that. TechCert, I'm assuming, is hosted at like Bluehost.com or GoDaddy.com, one of these giant providers. So if I have it shared there, let's just say Bluehost.com. Bluehost hosts literally, I think, millions at this point of websites that people pay them, $4 a month or whatever, crazy price they're giving people. So they have millions of websites. Well, you know what? They don't have millions of IP addresses. So they have, we'll just say, one IP address. address, 5.5.5.5. Matter of fact, I can tell you exactly what IP address they're using. Ping techcert.com. So 50.60. So this is the IP address that they're actually using. But how many other websites are they running from that one IP address? Probably hundreds, if not thousands of websites, right? So the question would be, well, how, I'm sitting out here, I type in www.techcert.com, that ends up pointing to Bluehost IP address, it comes to the server. How does that server know to serve up the TechCert webpage and not the other 100 websites that are hosted from that same server? And that's all done using a host header. I'll just put HH, a host header. When your browser, Internet Explorer, Firefox, Chrome, Safari, Mozilla, whatever you use, is requesting the website, it actually puts in the header, like if we were to open up Wireshark, it would say, I'm actually asking for techcert.com. It's in the application data of the header. And so the web server looks at that and goes, oh, okay, there's 100 websites here at this IP address, but you know what? I can see exactly that you're asking for it. Now, here's the problem. We just created a CNAME called techcert-cbtnuggets-aws.com, which points to this. So this will actually be in the host header when I go to the browser. So my guess, let's try it. Let's try it. It might work. I really don't know. I'm going to go to techcert.cbtnuggets-aws.com and hit enter. Oh! It worked. Great. Didn't demonstrate what I was talking about, but it worked nonetheless. The beauty, well, actually, you know what? I didn't even think of that. Okay, let's try another test real quick. Hang on. Do this with me. I'm going to create a record set. Let's do this. Let's create a record set, and let's do techcert2.cbtnuggets-aws. And this will actually be an A record. So here's my thought. Where is TechCert? Ping techcert.com. There we go. I'm going to take this IP address and plaster it in there. Bam. Hit create. Here's my theory. My thought, and I'm almost guarantee you that this is what's happening, is I typed in techcert cbt-nuggets-aws, it came back and said, oh, this is a CNAME to techcert.com, and my web browser got that and was like, oh, okay, well, I'll put that in as the host header. So what I'm doing is I'm just putting in techcert2.c, pointing it to the IP address of techcert, and my guess, I was just giving it 60 seconds to replicate. Let's just try that now. techcert2.cbt-nuggets-aws.com. Okay, good, pointing to the right place. Let's just take that, shoop, copy it to the clipboard, and then come up here and paste it in. TechCert2, cbt-nuggets-aws. I bet you it worked! That's awesome! But you know what that probably tells me? I bet you what Adam did, because Adam is a nerd just like I am. I bet you he actually moved TechCert to a dedicated server with a dedicated IP address. I guarantee you that's what he did, because otherwise that shouldn't work. Alright, I paused the video and verified. I typed the IP address right in there and TechCert appears. So whatever Adam has going, wherever that website is hosted, he has a dedicated IP address or a dedicated server or both or something. So mystery solved. Let's go back to the console, and I'm going to go to my hosted zone, cbt-nuggets-aws, and we've now seen the A record, the CNAME record. Let's do an alias. I'm going to hit create record set. And you can see we can type in whatever name we want, then the type, but we're actually going to ignore the type. I'm going to say, sure, it's an address record, but I'm going to check the yes on alias. Now you remember, aliases are the proprietary AWS records that point directly to an AWS resource. And you can see right now I don't have any targets available of S3 or Elastic Load Balancer or CloudFront, but I can point it to another record in this zone. These are the other records, A records that exist in this zone. The benefit of having this is it just eliminates the complexity and another point of failure. For a lot of resources, when you spin them up in Amazon, they get dynamic IP addresses, dynamic host names, and you have to say, okay, well, I need an Elastic IP, and I got to remember that, and all that. Well, you know what? Just create an alias record, and then point it directly to the resource. Then whatever IP address or whatever DNS name it ends up getting assigned, the record will still point to it correctly. Again, just eliminates another point of failure. Let's do it. I'm going to go and create. Oh, clicked in the wrong place. Let's make this bigger. Let's create a website. I'm going to go in S3 and let's add a bucket. And we will call it fluffy. CBT Nuggets, you'll see what I mean in just a second. CBT Nuggets, AWS.com. Hit create. I've got that. Now, I chose that name for a very particular reason, and I'll show you that in just a second. But before we do anything else, I've got to put some content in it. Let's go add files. I know I'm giving away my my plan here. So I now have fluffybunny.jpg. Okay, let's go back to the properties of this bucket. I'm going to first off change the permissions. Let's add more permissions to this bucket and say everyone can view, and we'll even say list. If they want to see what's in this bucket, that's fine. I'll click on save, so I've got some permissions there. Then scroll down and do some static website hosting for this bucket. We'll say I'm going to enable website hosting, and I'm going to have the index document, the default document, be fluffybunny.jpg. Save. So now I actually have a website pointing to this bucket, but I don't have DNS pointing to that bucket. So let's hop back here to Route 53, hit my hosted zone, CBT Nuggets AWS, create a record, and we will call it Fluffy. Now, notice, what did I do here? I'm naming it the same thing as the S3 bucket because that is what allows it to appear in this S3 website. If you don't name it the same, it actually will show up as a non-target. Now that's not so you might say, well, I've got a bucket. It's not named the same. Is that like a showstopper for me? No. You can actually go and type the resource name manually, this S3 website, blah, 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 and put it in there as the alias target. You know, typing it manually like that. It just doesn't automatically show up like it does when we name it the same. So you can call it a bug if you want to. I kind of would be like, yeah, that seems. You would think it would just show all of the S3 website endpoints, but it just doesn't. Okay. So we type that in there, and that, click on create, is now how we created an alias record for it. Now let's test it. I know I haven't waited the 60 seconds, but let's just see. And let's look up. We'll do fluffy.cbtnuggets AWS.com. Yeah, we're good. Record exists. So it actually filled in the IP address of that S3 bucket behind the scene. Now, let's do it. Fluffy.cbtnuggets AWS.com. Oh, man. Really? Okay. Hang on. Troubleshooting. It was like such a pinnacle. That was like oh, access denied. So obviously, I'm guessing I don't have permission set on the actual file. I just set the parent bucket folder. So hang on, let's look at this guy. Properties of that file, permissions. Yeah, I thought so. All right, so we will give everyone view permissions. Let's give them open download to. Why not? And save to Fluffy Bunny. Okay, come back here. I'm going to hit the F5 key to refresh. Oh, come on. It was worth it. All right. Oh, my goodness. I get paid to do this. I have too much fun. This is, anyway. So, what have we learned today? We have learned, wait, no, there's more. We have learned at this point how to, oh, there's a lot more. Okay, domain registration. We have seen the hosted zone resource records. I mean, and again, we could go all day creating the different resource records inside of here. Hosted zones and CBT Nuggets, AWS. I mean, MX records. If you've done DNS before, this is not a new thing. These are all standards-based records that you can create. So I'll let you explore the rest of those, create some MX records if you want to for your email down the road. But what I really want to show you is how we create and set up these Route 53 redundant records. These are not as self-explanatory as I would like them to be, so let me add some explanation to them. We've already seen one type of redundant DNS record, and that is this guy. Amazon CBT Nuggets AWS.com. It's an address record that points to 2 IP addresses. So it's going to round robin between those as we saw earlier. Now, keep in mind that is not a failover record. That is not going to be something that detects one of those being down. That's where the health checks come in. That's a little bit later. So if you have one of these IP addresses that is down, it's just going to give every other user a dead link, right? So let's start looking at some of the different routing policy-based records. So I'm going to click Create a Record Set. And we'll start off with weighted. So we'll name this one weighted. Oh, if I type in there, weighted. .cbtnuggets.aws.com, and I'll say this points to, let's just say 1.1.1.1. This is, and this could be an alias, it could be an A record, it could be a CNAME, it's whatever you want, but it's going to use the weighted routing policy, and it comes up and says, okay, we will respond to the queries based on the weight that you specify. So I can come in and say, okay, the weight of this record is, and you give it a number. Now what does that number mean? Nothing. It's relative to you and all the records you create. The way weighted works is I say, okay, I'm going to have weighted.cbtnuggets.aws.com, and it will have a weight of, let's just say, 80. I'll then create another weighted.cbtnuggets.aws.com, and I'll give that a weight of 20. Now, it uses these relative to each other, so it's going to go in and say, okay, well, 80% of the requests. So remember, somebody out there is looking up weighted.cbtnuggets.aws.com. They come to the AWS server, and 80% of the time it will respond with this IP address, whatever we've assigned there. In the case that I'm creating, that'll be 1.1.1.1. Right? And then 20% of the time it's going to respond with the other guy. And I haven't created that record yet. Now, where it gets funky, and if you're studying for the AWS certification exam, you can imagine they're going to get funky, is what if I type in 80, 20, and then I create a third weighted record, and I say, and that one's a 30. Well, you just messed up all your math, right? And that's why I say these numbers are relative, is because they're all percentages of each other. The secret, or the way to figure it out, is to add all the numbers together. So let's just say in this case it's 130, and then divide each one, this is basic math, divide each one by that divisor. Man, it's been, I'm like, this is basic math. Like, okay, what was it? It was the dividend or the divisor, or right. So this will actually generate the percentage of requests that will end up going to each one of those, because again, they're relative to each other. So let's follow the rest of the way through. I'll give this guy, let's just give this guy a weight of 20, right? And I'll say this is part of the set ID. Now this is confusing. You're like, the set ID does it have to be the same set? No, this is a description of this record of the set, because later on you may come back to this and be like, oh, what was this weighted? What was the other one? We can say, well, this is actually the London server. I don't know why. London server's going down. That just popped into my head. So I'm going to go create another weighted set, and we'll do weighted.cbtnuggets.aws.com. We'll have it go to 2.2.2.2. Right? Routing policy weighted, and this one we'll just say is 5. What is the set ID? This is California. Create. And that's how you create a weighted set. So you have one of them taking 20, the other taking 5. If you wanted to say, okay, well, what does that break down to in a percentage? Well, I'll say 20 divided by 25 is 80. So 80% will go to this first one, and obviously 5 divided by 25 is going to be 20, right? 20% ends up going to the second one. So that is the weighted record, one way of doing a more sophisticated balancing with that. Now let's move down to the latency. Latency allows you to specify latency-based DNS replies, meaning Amazon is always maintaining the latency between different sources of the world. And this is where I say it's not as self-explanatory. So you've got the world. Don't mock me. That's the world. So Amazon, actually, because they run GeoDNS, which is yet another DNS type, essentially takes all the IP addresses of the world and breaks them into the regions that they belong into. You know that you can go and do a go on the web and do, what is it called? Visual trace route. You ever done one of these things? A visual trace route tool where you can type in whatever IP address you want. Let's just say remote IP address is google.com. Let's just go with that one. Host trace. So we can actually determine, based on where we're coming from, this is where I go through to get to google.com. It ends up being 15 hops in between, and you go, how did it know that? How did it know google.com is sitting there in San Jose, California, or whatever IP address you typed in there? Well, all the IP addresses of the world are assigned to ISPs, and those ISPs all have physical locations. So what Amazon does is they say, okay, based on the IP address that you come from, so let's just say there's a guy, let's see, this must be California. There's a guy here on his computer, and he goes to, he says, I want to serve to latency.cbtnuggets.aws.com, right? He types that in his browser. Well, that's going to trigger a DNS lookup, and that's going to end up going to one of the AWS DNS servers here in the Atlantic Ocean, the AWS DNS server, and it's going to say, okay, well, based on your source IP address, little friend, this host right here, I've got latency tests always running. And this is the thing that I want you to catch. When you see this and you start saying, okay, do I have to say this is the ping and all this kind of stuff? No, no, no. You've got latency tests always running. He's going to say, okay, based on the records that are created for latency.cbtnuggets.com, the fastest one to you will be, South America region or something like that. Let me create the records, and I think it'll make a little more sense. So I'm going to say, let's go to create a record set. And we'll call this latency.cbtnuggets.aws.com. What value? Again, it can be anything. It can be an alias. It can be an A record. It could be a CNAME. I'll again just say this is going to 1.1.1.1. Routing type latency based. And I'm going to say this is the record that I prefer for US West, meaning this is going to be in the West region. This is the region that is located in. And I'll just say this is the California server. So I've created my first latency record. Now let me just add another record set. Create record set. We'll call it latency.cbtnuggets.aws.com. This one going to 2.2.2.2. It could be anything. I'll choose latency. This one will be the preferred one, or located in the US West 2 region. And we'll just say this is Oregon. I don't know where the US West 2 or US East 1. So these are the different regions of Amazon Web Services. So I've created 2 different latency records. So what happens with this? Let's say, let me just grab my red host. Somebody in Florida, right here, says, I want to go, they open a web browser on their computer and they say, I want to go to latency.cbtnuggets.aws.com, right? What happens? That request goes to the Amazon web server, or whatever DNS server is closest to them, right? And it says, okay, I see your source IP address, Florida friend, of 5.5.5.5. So I'm going to look at my latency database. It doesn't right then do a ping to those servers and say, oh, okay, which one's faster right now? No, 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 no. Amazon is always doing latency tests to their different regions. And it says, okay, Florida friend, I actually have a record from you, sorry, I've got 2 records for latency, one going to West 1 and one going to West 2. Based on your source IP address and based on the region, again, Amazon has this big matrix database, and they say, okay, well, the Florida region has 100 millisecond response time from West 1 and has 150 millisecond response time from West 2. So I'm going to return to you the IP address from West 1. Right there. Florida friend. Does that make sense? I feel... I can, like I said, this is one of those things where it's like, huh? Can you say that again? I absolutely can. Let's go, let's do, let me do exactly the same example I just did, and that'll make it clear. Let's say I've got someone in Australia. Australia opens a web browser and says, hey, I want to go to latency.cbtnuggets.com. Right? So they put that in there. That's going to go to one of the AWS DNS servers. The AWS DNS server looks at the record and says, okay, I've got one record for latency.cbtnuggets.aws.com that points to US West 1. And then I've got one record here that points to US West 2, which, again, I don't know if this is the actual location. Actually, I don't think it is. But one's in California, one's in Oregon, right? So Amazon looks at its database and says, okay, you're coming from Australia. You have a source IP address in Australia. My database says that the latency from Australia to West 1 is 200 milliseconds, whereas the latency from Australia to West 2 is actually 80 milliseconds because we've got some fiber links going, whatever. So what's going to happen is the DNS server is going to return the IP address to the Australia computer of 2.2.2.2, which is US West 2, the one it had less latency for. That, for some reason, I just felt like that was a clearer explanation, even though I just said exactly what I said for the Florida one. But does that make sense? Does that help? Okay. All right, let's jump into the failover record set. This one's actually really simple. I'm going to click Create a Record Set. We'll call it failover.cbtnuggets.aws.com. give it to 1.1.1.1 is where this one's pointing to. You hit the routing policy and you hit failover. And essentially the way failover works is you have a primary and you have a secondary. It will always give the IP address of the primary unless the primary is down. Then it will start giving the IP address of the secondary. So, matter of fact, you can see the health check. This one would be essential. I don't even think it'll let you create it without a, it's saying you've got to have a health check because otherwise it doesn't know if the primary is down or not. So, we haven't talked about health checks yet. We'll talk about that in just a moment. But essentially, the health check allows you to come in there and, we haven't created any health checks. Allows you to say, I'm going to ping whatever server. And then when that's down, it'll flip over to the secondary. So we would create one that points to the primary, one that points to the secondary, and it will always go to the primary. The set ID is just a name that differentiates this record. So I can say this is my big server, and then the secondary can be the small server, and so on. But we've got to have health checks in place to create that. So let's hit the last one, geolocation. So I'll call this one geo. Geo.cbtnuggets.aws.com. This one is going to take some work. This allows you to go through and set a specific server for every location of the world. Yes, really. So I can say I want to go to Samoa and say that Samoa, if they ask for geo.aws, cbtnuggets.aws.com, Samoa will always go to 1.1.1.1. And I can create that one. And then I'll go to create a second one, and we'll call it geo.cbtnuggets. You see how this thing works? Geo.cbtnuggets.aws, and I'll say if somebody goes to Asia, anyone in Asia that asks for this will go to 2.2.2.2. Other server. Right? So you would literally go through, if you really wanted to, and assign every particular region of the world to a location. Now you might say, well, I don't want to do that. I want to use GeoDNS, but I don't want to go to every location of the world and assign it. What's my other option? Well, that's where you want to make sure, absolutely make sure that you have a default location. So essentially, the default will be if you go to if someone in a location of the world that you haven't set up requests geo.cbtnuggets.aws.com, then it will go to whatever you've set as the default location. If you don't have a default, they won't get a response. So you want to make sure. Yeah, I'm going to bite my tongue. Hang on one second. I got to verify that. Yep, just did. If you don't create a default resource record set, Amazon Route 53 returns no answer for those locations. So, yikes. That's one of those things you want to make sure you have a default, because if, let's say, South America asks for it and you haven't set up South America, then it's going to just say, oh, sorry, there is no geo.cbtnuggets.aws.com. So that is how the geolocation feature works. That is the Route 53 redundant records that you can have. Whoa. Redundant records that you can have. Pretty sweet. Now let's hit health checks. Last thing that we've got. The health checks, you probably have seen it at the bottom of every single one of these records that we've created. Associate with health check. Associate with health check. They all have this option. Now the basic A record, if I go to right here, just a basic non-AWS fun and fancy record, does not have a health check, because these are standard DNS records. But if you use, for instance, an alias, you can say, I want to evaluate the target health. And that allows, especially with the alias records, Amazon behind the scene to evaluate the S3 bucket. And if the S3 bucket's down, it will remove that as a reply to fluffy.cbtnuggets.aws.com. But all of these also have, at the bottom, any of these latency-based, geo-based, associate with health checks. So if the target is down, if 1111 fails, 1111 fails, it's going to pull it out and not respond to people with that IP address anymore. Now, you can see right here that there is no health checks, so let's go over and configure some. We can create health checks either very specifically, like exactly that host, exactly that port, or generic. I can say, you know what, if that server's down, I don't want to send it to this group anymore. I mean, there's many different ways to do this. Health checks have the ability to test HTTP, HTTPS, and TCP. So you can go in and, when you say TCP, you can specify whatever port number you want. But notice what gets grayed out. You can see path and hostname go away. This goes back to what some of the stuff I was talking about before with the host header. So I can say I want to have, let's just call it server 1. And I can say the IP address will be 1.1.1.1. We can also choose a domain name if I want to go that route. And I can say the host name, optionally, would be fluffy.cbtnuggets.aws.com. And so the health check will actually request that host name. So that way, not only if port 80 stops responding, but if that host header stops responding, meaning maybe Apache itself freezes behind the scene, or somebody misconfigures the server, you can pull it out of the list. You can even have it request a certain path and say, yeah, well, fluffy.cbtnuggets.aws.com/images /file.html. I want you to request that file once every 30 seconds, and if you don't hear back 3 times, so 90 seconds later, consider it down and pull those DNS responses out of there. If you want to go fast, for a price, you can. And you can go and say, I want it to check every 10 seconds, but it does increase the fee that you pay for these health checks. These health checks are, you can see these health checks, basic plus, they are, I think the first couple basic health checks are free, but the fast ones you always pay for. There's something. The pricing's always changing. So check that out. Now you can even go further and say, I want to look at the response and make sure that it always has this string in there. That way, if something is bad with the response, you can make sure that you pull that server out. So again, as detailed as you want to get, you can get there. So I'm going to hit create. And now I've got a fast health check running every 10 seconds that is making sure that that's up and running. Now, truly, there really is no server 1.1.1.1. So the health check will immediately start failing, and within 30 seconds, anything that's assigned to this health check will get pulled out of there. But let's just complete the puzzle. How do you assign something to a health check? Well, you go there, and I'll say anything assigned to this 1.1.1.1 will be associated with the health check of server 1. What is that? Recommend that you a time to live. Oh, yes. So it's just saying that with your response, you should have a time to live, meaning a cache of 60 seconds or less. Click on the 1 minute flag there, so that if the server does go down, the computers will not cache this DNS response any longer than necessary. So they're saying, set that to 30 seconds. If you have that fast ping, you don't want to have people caching this data, and even though it's quote-unquote failed over, it doesn't actually impact the client until their cache expires. That makes sense? So I click on Save, and now this server associated with this health check will no longer be assigned as a response, because that, I'm guessing, let's just verify, there truly is no 1.1.1. Yeah, you can see there's no response coming in here at all. Failure threshold, we've got 10 seconds, it's dead. So I'm just pure curious. So let's, hang on, we assign that to, well, I'm not in Samoa. Anyway, you can go do an NS lookup, and you should see that it's only returning 2.2.2.2 from that response. So that is how you configure health checks, and you can configure, again, as many health checks as you want and assign them to your DNS target so it will actively respond to failures in the system. Wow, if I were to describe this nugget, I would just say this has been a meaty time. This just felt like this is exactly what you need to configure everything in Route 53 for your environment. So we have seen how to register domains, setting up the resource records, setting up the redundant records, and the health checks. I hope this has been informative for you, and I'd like to thank you for viewing.